This video, we're going to now start making our light blink, or we can set a digital output for our robot if it crosses a threshold on our device. So just kind of show you what we're going to kind of program. I have a circle program created here. And if I run this circle program, so the basic premise is this is safe position. As soon as it goes through this is unsafe position. So that means a robot can actually run into it. And right now I have all the rest of the robots and the tables hidden and turned off so that we can run these devices. So you can see we're running. And as soon as we hit this, it should go into a caution saying that, hey, other robot, I'm in this position. Don't go to this position and crash into me and, cost me millions of dollars of repair. Okay, so we're going to go through and we're going to start setting that up. So again, the previous video, we set up our data registers to constantly update our X, Y, Z, WPR positions for inside our data registers. And now we're going to utilize that in our program to tell the program to make decisions based on where that robot is in the XYZ WPR positions. So let's start programming this. So I wrote a very simple program on a Word document, just kind of show you what we're going to be planning on doing. So we're going to be doing some while statements. Now, FANUC doesn't actually have a while statement, so we have to change an if statement to turn into a while statement, but just kind of show you in a computer programming terms of what's going on. Okay, we're going to have a separate program running in the background that is non-motion, which means we can do parallel tasking with a motion group. So we're going to do a while the robot is moving, we're going to turn on a green light and turn it off. So when it's in a safe position, we're going to have the light blinking. So on, off, on, off, on, off. When it's in a unsafe position, we're going to have a yellow light on. So turning on, turning off, turning on, turning off. We're going to constantly jump between here based on a few things. Number one, is the robot running? If the robot's running, then this program's going to run. Number two, we're going to have a robot is in the safe position. That's where that position data comes into play. So if it is greater than or less than that Y component that we're going to utilize, we are in the safe position. If it's more than that, we are in the unsafe position. So this is a way of programming that is very quick, very easy to do, but there is a lot of problems with this. So when we look at this, when we're making decisions, we want to make decisions on the fly. Okay, so if we enter this loop right here, robot is moving and the robot is in a safe zone, it checks to see, okay, so robot is moving, the robot is in a safe zone. We're going to turn the green LED light on, wait half of a second, turn off, wait half a second, and then it's going to loop back and it's going to check this while again. Robot is moving in safe position. Turn green LED. So it's constantly doing this over and over and over again. And the only time that this argument is being checked is after these lines of code has been ran. So it runs through this, waits here at 0.5 seconds, waits here at 0.5 seconds. So hopefully you can see what is the problem with this. Okay, so the problem with this is, say we enter the unsafe zone, but we are right here when it comes to the line of code. Okay, so we're in that unsafe zone, but until we get past this wait, it's not going to check this area right here. So we can be moving into that unsafe zone and still have a little bit of time left before it actually checks to see if it's in that unsafe zone. And that time could be a matter of a couple seconds. It could be half of a second in this case. If we turn this up to 1 second, it could be 1 second. And that could be a matter of crashing a robot. So there are better ways of writing this. This is an easier way of doing this. So this is where we start out when I'm teaching computer programming. This is where we start out with writing. Wait is bad. Don't do wait unless you know everything is ending and everything is good and nothing's going to crash. Okay, so if nothing's going to crash, waits work perfectly fine because they're very easy to program. The way that you actually want to program it, which is more involved, but it is always checking to see if it's in safe position, is up here. So this is a better way of programming. So we're going to utilize a while statement within a while statement. So while the robot is moving, we're going to run this program. So while the robot is moving and we are in the safe position. So inside that, we're going to have timers. So we're going to utilize timer 1 and timer 2 in this program. So while our robot is moving and the robot's in the safe position and the timer is less than a half second, turn green LED on. So what's happening is it's going to constantly turn the green LED light on, which is already on. So it's not actually going to do anything. So it's not going to blink or anything else. But it's constantly checking this while statement. There is no waits to stop this. So constantly checking. So is it in safe zone? As soon as one of these arguments become false, it moves out of this and checks the next item down the list. Okay, so all of these, because it is an AND, have to be true in order for it to run this argument right here. So if these arguments become false at any point, it jumps out of this loop and moves on down through the program. So here is, we are in moving and we are in a safe zone. Here is robot is moving, we are in an unsafe zone, which means the robot is still moving. Robot is in an unsafe zone. That's where we use that data registers, make it equal to or less than equal to that whatever position we are. And then our timer's less than half second. And then as soon as both of these are, it jumps out and then it continuously loops over and over and over again. Okay, so this is a lot better way of writing the code where it's constantly checking the safe zone, see if we're in that position. Because the moment that data register becomes that 25 or whatever number we find, it jumps out of that loop. It's not waiting on something. It's not stuck at a line of code. So the next thing is, how do we turn this into a workable item in FANUC? Because FANUC does not have a while statement. FANUC has a for loop and an if statement. So what we have to do is we're going to switch this to an if statement. So with an if statement now, it's going to look at this. If this is all true, it's going to run through this. Now, we need to make sure that this is looped, so we're going to go to a jump label, and we'll say jump to label 1. And then before the if statement now, we're going to have our label 1. So now what's happening is we just turned an if statement into a while statement. So it skips past this the first time it runs through. So if this is true, it goes into the if statement and turns on our yellow LED, jumps out of that into label 1, jumps to label 1. Is this still true? If it's still true, runs this program, jumps to label 1. Here's label 1. Is this still true? If it's false, then it bypasses this whole bracket and then goes and moves on and down the line. So it doesn't go into that jump label. So we need that jump label inside of that if statement and jump before the if statement in order for this to work. So this is how we do a while statement as an if statement inside RoboGuide. So let's actually go in here and start creating our program. So inside RoboGuide, let's go create, and let's create a program called Blinking Light. We'll call it for safe. And then we're going to go to detail because this is a non-motion. We're going to just blink a light and doing digital outputs and digital inputs. We're going to go to group mask and we're going to go to an asterisk. So this is again big thing because we want to run this parallel to our robot. So as the robot's moving, this is updating in real time. Otherwise, this will become part of the program in which then it just becomes a huge problem. Okay, so we're going to do an asterisk here and we're going to go to N. So the first thing we want to do is make sure all our lights are off. Now I did write a sub-program already for lights off, and I'm going to just jump in there just to kind of show you what it is. Basically, digital 10, 11, and 12. 10 is my red light, 11 is my yellow light, 12 is my green light. So inside my light off, it's digital output 10 off, digital output 11 off, digital output 12 off. So that turns my lights off. So it's all under the light off program. So I'm going to go back to my light program and we're going to call that program. So we're going to go instructions and we're going to go call, and we're going to go call program or light off. Next, we're going to be utilizing some timers. So let's add some lines here just to make things a little bit easier. So I'm going to add like 20 lines. So we call the light off so that the light is now off. Then we're going to do is turn on timer 1 and turn timer 2 on. So we're going to go instruction, miscellaneous, timer. So there's some background timers that we can utilize. Right now they're off. We're going to turn them on. So timer 1, and we're going to start timer 1. Same thing with timer 2. So we're going to use 2 different timers in this. Miscellaneous timer 2, and we're going to start. Okay, so now that we have those timers started, we're going to jump into our first loop. So before the loop, remember, when we wrote this, we need to have a label. So we're going to go label 1. So we're going to new instruction, and we're going to go to label 1. So this is going to be our first while statement. So then we're going to go to if statement and if then, and we're going to look at our if then now. So I just went to previous so we can see what we're doing. So if something happens and it's true, then we're going to do something. So this is going to be our first while statement. So what we need is to have some sort of argument that we can call upon or you can use in another program. So I like to use registers. So under data, if you remember when we went to set up the XYZ WPR, you have a 1 under register number 3, which is called argument. So if we say argument is equal to 1, then we're running. If argument is equal to 2, then the robot is not running. So we can set these to say true and false, or we can set it to 0 and 1, much like binary. So if we would set this to say 0, then no, it's not running, and then 1 will be yes, it is running. So we're going to utilize that with binary. So we're going to edit, and inside here we're going to use our register number 3, which is our argument, and then we're going to start putting in our argument. So if register 3, which is our argument, insert is equal to a constant, which is going to be 1, which means it's running, okay? So if equal to 1, which means that the robot is running, then we're going to run this program. Then we're going to go down to 7. So now this is going to be our first initial items. So all the way down here, I'm going to do my end if to kind of close that bracket. So all the way down here, I'm going to go my end if. So if select, and then we're going to go end if. So that's going to be my close bracket. So everything inside this is going to be that if statement. Okay, so if we're at that, then we're running through there. If we're not, it's going to exit this. So it's going to exit this, and it's going to go right to the end, okay? In which we're going to stop all the timers. So we might as well add those timers right here. So I'm going to insert another 2 lines here, and then we're going to turn off those timers. Okay, so if we're not utilizing them, then we want to turn them off. So we're going to miscellaneous timer 1, and we're going to turn off. So we're going to miscellaneous timer 2, and we're going to stop. Okay, so once the robot stops, we're going to exit that if statement, go to line 21, which there's nothing there, go to line 22, timer off, ends the program. So let's go inside here now. So this is our first initial if statement. So if the item is running, then this is running. So then what we're going to do is we're going to start adding our different if statements inside here. So if I go up here, so while a robot is running, so here's our first while statement. So robot is moving. So then we're going to go into another if statement. So if the robot is moving and we are in the safe position zone. Okay, so let's go inside our robo guide. So we're going to do another if statement. And we're going to do if then. So if our register number 3 is equal to constant of 1, which means it's running. And then we're going to go and we have to make sure that our position is correct as well. So we're going to go register number 11, which is our Y component. So that's our Y position. Okay, we set this up in the previous video. So now we're taking that real-time position and we're looking at that. So now what we need to do is figure out, okay, what is this actual number? So I'm going to actually just put it in as a data register for now, and then we'll put it up at the top. So I'm going to go insert, and to the left is less than, to the right is greater than. So if we're doing the safe position, then we're going to go less than equal to. So less than equal to, and we're going to register number 5, okay, which is nothing right now. So less than equal to register 5. So let's set up that register 5. Go to data, register 5. Well, we could have used register 4, but let's just use 5. So we'll call this safe thresh. So safe threshold, enter. And this is where we put in that number wherever that box hits our threshold. So we're going to have to figure out what that number is. So instead of having here where somebody could accidentally change it here, let's go into the actual program and let's hard code this in here. So I'm going to go up here where it says call light off. I'm going to go insert one line. And then we're going to add that data register. So we're going to go registers equal to, and we're going to use register number 5, which is our number, and we're going to equal to constant of whatever number that is. So we'll say 20 at this point. Okay, we'll come back and change this once we figure out whatever it actually is. Okay, so our safe register will equal to 20. So now, even if somebody changes that register by accident, this will automatically hard code that as 20. Okay, so going back down here. So if our machine is running and our Y position is less than that threshold, then we want our green light to blink. So let's go in here and let's just add the end ifs just so that we have some space and we don't forget about it. So let's go in here. Let's go if statement. So end if, and then we also want to make sure that we are jumping to the label because this is a while statement. So we have to utilize the jump statements as well. So let's go inside here, jump, and we're going to jump to label 2 in this case. And then before this, we're going to have label 2. So we're going to be inserting a lot of lines as we go through here. And then here's where we're going to add label 2. So again, just kind of running through. So here's our while statement. So this is what we just wrote, is this one right here. And then if I go down all the way here, this is how we set it up in RoboGuide. So jump label, here's our if statement taking the place of an actual while statement. RoboGuide does not have while statements, or FANUC does not have while statements. And then we need to have a jump label inside that bracket. So that's where we have the end if here as well. Okay, so that's that curly bracket. So then we have the then taking the place of the brackets. So then is that first initial curly bracket, the end if is the second curly bracket. These are the lines of code in between those brackets. So this is what we're creating right now, and then we'll have our lines of code in between. So let's not forget about those things. So this one is label 1. Let's do that as well down below. So let's go all the way down to where that other end if is we created. Here's where we're going to do that jump label, and we're going to jump to label 1. Okay, so then the end if. So that's that first initial while statement. Here's our second while statement between 9 and 13. Okay, so this is if we are in position, in safe position, and we're running, then we're going to run this. So now I'm going to insert a few lines here. So we'll insert, say, 10 for now. Here's where we're going to now do our next while statements. So the while statements are going to be, we're going to blink the lights. Okay, we're going to blink the lights. Statement, so we're going to do the if, then, and then select. So here we're going to add the label right away. We're going to do label 3, just going right down the line. And then we're going to do our if statement. If, and then we're going to go then. So if register number 3 is equal to 1, and our register number 11 is less than equal register number 5, which is our safe position. So first, again, we're checking to make sure the robot's running. Then we're checking to see if we're still in the safe position. Now we're going to add the timer. And our timer, so go next page, timer number 1 less than and equal to half of a second. So we're going to blink half of a second. So 3 arguments of AND statements. So now before we do this, we also have to reset the timers. So we need to add a line here. And this needs to go before the label, okay, so not in between. Otherwise, it constantly resets and it never leaves that loop. So we're going to go in miscellaneous, and then we're going to go to timer, and we're going to go timer number 1 and reset. So timer reset then goes into the while statement. So it's almost instantaneous that it goes into this if statement after we reset it. Okay, so then inside here, let's go to line 15. So once we are actually inside this if statement, then we're going to turn on our green LED. So we're going to go IO, digital output number 12, which is our green LED light. We're going to go on. Okay. And then we're going to do our end if. Now we already created that end if, which is right here. So all we need to do is get rid of these extra lines. Okay, so that is our first actual while statement inside here. So we reset the timer, bypasses that label 3. If our argument is good, our Y position is good, our timer is still less than 0.5, then we have our LED light on. And it constantly jumps back to label 3 here. And I accidentally didn't create this, so what I'm going to do is just go inside here, change this to label 3, and then we need to do our jump label down here. So for label 2. And then we're going to do the end if, because I accidentally used label number 2's end if. Okay, so we have label number 1, label number 2's end if, and then here's label number 3. Okay, so I accidentally used this one right here, end if. Okay, so just make sure that you're keeping up with the end ifs, because that is just like closing the brackets for each of the different conditions. Okay, so label 3, end if to this if statement right here. Okay, so now that we have our green LED on, now we need to turn it off. So what I'm going to do is I'm going to go ECDM and I'm going to copy this because I don't want to do this all over again. Down, and I'm going to go copy. Then I'm going to skip a line and I'm going to go paste. And we're going to just go logic because there's no other logic in here, or no other points that we have to worry about. Okay, so now we're going to use timer number 2. So we're going to go reset timer number 2. We're out of that copy area. And this is label number 4 now. So the argument is still valid here. And we're going, instead of the green LED on, we're going to turn it off. So we're going to go choice, off. And then we're going to jump to label 4. Okay, so it's very simple to do after you create that first copy. We go into here and then we paste it so that we have our item. So this is if our argument is equal to 1, which means it is on, robot is running. If our safe position is good, so Y position is less than our safe threshold, and the timer is 0.5. Oh, forgot to switch to timer 2 here. So right here, timer 1, timer 2 is less than 0.5. So this is the safe position area. So we got these two done now, okay, which is in this while statement. Okay, so now we need to do the same thing. While our statement here, we need while our robot is moving and also in the safe position, and we're going to do the same thing. So if you remember, this is label 1, this is label 2, this is label 3, and this one is label 4. So now we need this while statement to be outside of label 2 and inside label 1. So we just have to make sure we nest this correctly. So if I go down, there's our timer 2 reset, and if, so here's label 2. So I'm going to delete this one line of code here, or one empty line, and then we're going to go our next points right in here. So I'm going to insert a few lines. 3 for now. So we're going to insert after our jump label number 2. So basically what we're doing is we're going to copy this whole thing right here, just changing this to label 3 or label 5. This is going to be label 6 and this is going to be label 7. Okay, so we're going to just change and update those labels, and then we're going to also change and update our robot position as well. So I'm going to go up here and we're going to copy this whole top part. So going all the way up. So here's label 1, here's label 2. Command, copy, select, and we're going to arrow all the way down. Copy, Go all the way down to that label 2. So in between here. So line 29, I'm going to paste logic. So line 29 was where we started. So here is label 2. So now again, this is going to be, we need to go in here and change these labels. Label number 5. Okay, so this is going to be, and we're less than, so we need to now change this so that we're in that threshold of greater than. So we're going to go choice greater than. Okay, not greater than equal to, but greater than. So that means we're in that unsafe position. Then we're going to reset that timer 1, and then this is going to be label number 6. And then we have to change our less than equal to, greater than now. So our Y position is greater than our threshold. Then we turn the yellow light on. So the yellow light was 11 on, and we're going to jump to label 6. Then going down, this is going to be label number 7. Label number 7. And still running, Y position is greater than our safe threshold. And the timer number 2 is less than 0.5 seconds. And we got to change our digital output to 11 is off. And then we're jumping to label 7. Okay, that's the end if. Going down here, this is going to jump to label 5. So this is this curly bracket right here. And then we have our end if. And then here's our label 1. So I'm going to go in here and delete a few of these lines. There's our overall label, and then turning off our timers. Okay, so we did a lot here. So it's a lot of coding to get our lights to turn on, turn off based on our safe positions. But again, just kind of running through this line of code here, and we'll just update the sheet to kind of show what it looks like. Okay, so here's our first label, if statement. If it's moving, then label number 2, second if statement, which is going to be in a place of while. If the moving and in safe position, then we're going to do the timer. So this is going to be the on, this is going to be the off. On, off. So it's constantly jumping between here, on, off, when it's in the safe position. Half-second increments. So turn it on, turn it off. So again, jumping the labels here. Once we are out of that safe zone, it jumps into label area of number 5. In the unsafe zone, turning the yellow light on, and then yellow light off. Now, sometimes you may have a scenario where you have the green LED on, so we may just add a program inside here that will turn off the LED lights, all of them, and then turn it back on here. So let's go inside here and find label number 5, which is right around line number 29. Here's label number 5 here. I'm going to just jump in here, and I'm going to insert 2 lines, and then we're going to just call that program where it turns off all the LED lights. Call program light off. So lights off in between here to make sure the light's off. Same thing up here. Let's just make sure the light's off if we are, once we're out of that position. So we insert after label number 1. So we have light off in between the lights, and then we're going to have light off here too, before label number 2. And that just makes sure everything's off, so that the yellow light is off and the green light is off. Okay, so now this program is running, so blinking light for safety. Next, let's create the program to see where our position is as soon as this box hits that threshold. So what we do is I'm going to hide this little frame part. All right, so now I'm going to write a program, just a quick one. So I'm just going to create, and then we just call it tester really quick. And go to edit, and we're going to now move this box so that is in line with that line. Just go to our coordinate, go to tool, and we'll bring this box so it's just hits that line. So you can see it's just about to hit that line there. So I'm going to go inside here and we'll create a program now. So I'm going to go point, and we're going to go linear here. And then I'm going to move it up, point, linear, and then down. And we'll just keep it slow like this so we can actually see the numbers happen. Because remember that those numbers don't modify unless we actually run the program. So we just run the program and we go to data while it's running. And we arrow down. There we go. So it moves up. Notice our Y position's at 23.72. So if we make this say 23 or even 24, we should be good. So running that. So that is going to be our threshold number. So let's go to select and let's find that program we created, which is the blinking light for safety. And I'm going to go inside there and we change my threshold number to 24. Okay, so turn on my teach pendant and change it to 24. So now I have my threshold. So now I can go into my circle program with my threshold created. This one's already created. So if I run my circle program, it goes up and it rotates around and then it hits inside that threshold and then out again. We're going to now add our program in the background for our lights that we just created. So I'm going to go up here to the top where my override is. So the first thing we want to do is maybe make sure the lights are all off. So edit. And I'm going to switch over to instruction, and we're going to go to call program, and we'll just turn the lights off. Then what we're going to do is we want to have the arguments calling on as well. So I'm going to go instruction and registers equal to our register number 3, which is going to be our argument, and we want to set that to our robot running. So we're going to set it to constant of 1. So that means our robot is running. Okay, so as soon as we hit that, our robot starts running. So insert 2 different lines here. Then what we need to do is we're going to call upon our light. Now we want to run this in the background. So we're going to go instruction and we're going to go to next and multiple control, run. And we're going to run our program blinking light for safe. Now that's going to run in the background and then it's going to do exactly what it needs to do. And then as soon as we're done with this program, we're going to turn off or set our argument to 0. I'm going to go instructions, registers, and we're going to set equal to our register number 3, and we're going to set it equal to 0. Okay, so if our argument becomes 0, then we're not running anymore, and the light will turn off with the robot. So this is how we're controlling the light on and light off for our actual robot. So let's go up here. Let's try this out. So I run my circle program and watch the light now. So we're in that safe position. Light's blinking green. As soon as we hit that threshold, it turns to yellow. Back again, green. So it continuously does this over and over again. And at the end of the program, the lights should turn off. And there we go, and the light turned off. So that means we programmed everything good. So now we have this on one robot. Now we can communicate that, saying we're in that unsafe position, to the other robot. So that's what we'll do in the next video.